Hello, this is Ms. Russell, and we're going to be learning section 9.2 today, angles and radian measure. So first of all, I want to talk about the objectives of our lesson. So we would like to be able to, number one, draw angles in standard position. 2, find coterminal angles, and 3, use radian measures. So I'd like you to have some paper, writing utensil, possibly different colored pens or pencils so you can color code your notes, and your calculator and a straight edge just in case you need them. Anytime you take notes, these are just some good supplies to have on hand. Okay, so first of all, we're going to talk about standard position. So standard position is an angle theta with the vertex at the origin and the initial side on the positive x-axis. So see here how I've drawn an angle in my coordinate plane. One of the rays of the angle is on the positive x-axis, so that is called the initial side. And then your terminal side can be anywhere. It's just where your angle opens up to, or where it ends or terminates, right? When we're looking at angles in the coordinate plane, if theta is positive, you would open up counterclockwise. If theta is negative, then you will open up clockwise. So we're going to move on to an example. So first we're just going to be drawing angles in standard position. So part A is 240 degrees. And if at any point you need to pause the video just to copy stuff down, feel free to do that. So 240 degrees. So if we're starting here, this would be 0, right? And halfway around is 180 degrees. And then another quarter of the way would be another 90 degrees. So we don't go quite that far, right? So 240 degrees is approximately here, and you need to draw from the initial side, which we don't actually normally see this drawn in, right? But we know that it's there, and we know that we're starting there if we're in the standard position. And so we're showing that our angle theta is positive, and we're showing which direction we're going in. So this is 240 degrees. And then we want to think about where exactly our terminal side will be. So we want to think about how much further past 180 degrees we go. And so 240 minus 180 gives us that we have a 60-degree difference here. You don't have to write this in, but this part will help you see where your terminal side should be. Okay, 500 degrees. So if you start at your initial side and you go all the way around, it's 360 degrees. And then each quadrant is 90 degrees, so plus another 140 degrees will give us 500. So we're going to go past this part. And we're only going to go, let's see, 50 degrees past that part. So this would be 500 degrees. And if you notice, right, if this wasn't labeled, but you saw this angle drawn in here, you could see that first of all, it's over 100 or over 360 degrees, and then you can see which direction it's going in if you draw the arrow on there. So you would know that your theta is positive because we're moving in a counterclockwise direction. Negative 50 degrees. So if we're negative, we're going to move in a clockwise direction. So again, we still have this initial side. We're just going to move this way rather than this way. So 50 degrees, we're about halfway into this quadrant. And we're done. That's it. All right. So the next thing we're going to talk about is coterminal angles. So you might want to pause this here and copy this down. Coterminal angles are where two angles are coterminal if they are drawn in standard position, which we just talked about what that was, and both have terminal sides in the same location. So you could have multiple angles that are in standard position that end in the same place. To find the coterminal angles, we're going to add or subtract multiples of 360 degrees, or later on when we're talking about radians, 2 pi. Example 2, we're going to find one positive and one negative coterminal angle for A, negative 45 degrees, and B, 395 degrees. Okay, so to find these positive and negative coterminal angles, we're just going to add or subtract 360 degrees. Negative 45 degrees, if we drew our angle, right, we would have to move clockwise. So negative 45 degrees would be approximately there. So negative 45 degrees, if we want to find a positive coterminal angle, we would just add 360 degrees. So we have 35 degrees. If we'd like to find a negative coterminal angle, then we would just subtract 360 degrees, which is, oh, I missed this. This is 315. I don't know why I put 35. Sorry. This would be negative 405 degrees. And we're done. Here's one positive and one negative coterminal angle with negative 45 degrees. Part B. So we're looking for 395 degrees. So 395 degrees, we're going to go around once and then a little bit past. So it's approximately here. This time, we're not going to add 360 to 395. If we subtract 360, we'll still have a positive number. So that's this one is equal to 35. That's why I made that mistake earlier, sorry. Okay, there are two ways that we can think about how to find the negative coterminal angle. So the first way would be to say 395 degrees minus 2 times 360 degrees. Or we could just think of it as 35 degrees minus 360 degrees. since we already know that 35 degrees is coterminal with 395. Either way, you'll get the same answer, and it's negative 325 degrees. So one positive coterminal angle and one negative coterminal angle. That's it. That's all we're doing here. Okay. Next, we're going to talk about radians. So radians, we have a circle, right, in our coordinate plane. And that circle has an angle, right, and it has a radius of r, right? We represent radius as r. We're looking at radians, so 1 radian is the measure of an angle. It's in standard position, right? Its initial side is on the positive x-axis, and this is its terminal side. So it's an angle in standard position whose terminal side intercepts an arc length of r. So this arc length is r. And then this angle, this theta. So theta is equal to 1 radian. All right, if we think about the unit circle, well, if we think about circles in general, the circumference, remember, is 2 pi r. If we think about the unit circle has a radius of 1. So the unit circle, the circumference is 2 pi. So if you go all the way around once, it is 2 pi. So we have to think about how this is related to degree measurements. So 360 degrees is all the way around, and that's equal to, in radians, 2 pi. 180 degrees is halfway around, so that would be equal to half of this, so that would be pi. If we want to convert between radians and degrees, we need to look at this ratio, right? So we have that pi is equal to 180, and we're going to use that to convert. So if we're converting between radians and degrees, if we're going from degrees to radians, we're going to multiply by pi over 180. Pi is in radians. We don't normally write this, but sometimes you'll see it written. And then if you're going from radians to degrees, you're going to multiply by 180 over pi, so just the reciprocal. And then the last thing that we're going to do is an example. So we're going to convert between degrees and radians. Part A, we start with 120 degrees. And so we're starting with degrees, and we want degrees to cancel out. Remember, we have either pi over 180 or 180 over pi. If we want degrees to cancel, then we're going to multiply by something that has degrees in the denominator. That might help you remember which version of this fraction you're going to use. So times pi over 180. And here, this is just over 1, and we can multiply straight across. So this is equal to 120 pi over 180. We want to leave pi in our answer. We don't want a decimal answer. We're just going to reduce this fraction. So we can cancel out the zeros, and then we can simplify 12 over 18. They're both divisible by 6, right? So 2 pi over 3. So you're kind of treating pi like it is a variable. So 120 degrees in radians is 2 pi over 3. Part B, we have negative pi over 12. So this is radians. We need to convert to degrees. So times the reciprocal of this, right? 180 over pi. We want the pi radians to cancel out. Pi in the numerator times something with pi in the denominator, they cancel. Negative 1 times 180, so negative 180 over 12. Oh, this is degrees, right? So we would just simplify this, so it'd be negative 15 degrees. That's all. Thank you very much.